The Volvo A60 is the largest articulated hauler in the world. It can effortlessly transport up to 55 metric tons of cargo, bringing its total weight up to nearly 100 metric tons. The XXL dump truck is built in Braås in southern Sweden. The A60 is the biggest vehicle produced in this factory, with only a few parts fitted by hand.
It needs a crane. Most things with the A60 need a crane.
Every part of the A60 is bigger than those for the other vehicles in the plant. Even the huge tires were specially designed for the A60. The factory had to be converted for the hauler.
The machine didn't fit into the gates. They needed to widen their gates in order to get the machine into the correct environment.
At the Braås facility, around 550 workers produce 6 different hauler models. Every hour, 2 finished trucks leave the assembly line. And once the dump trucks are in action, there's not much that can stop them. They're hardcore vehicles, practically indestructible. Braås, southern Sweden. This plant produces 6 different dump truck models, chief among them the A60. The first step is cutting the sheet metal down to size. This high-rack warehouse has 176 storage areas, housing all the different thicknesses of material that will be needed later. Each sheet goes onto the laser table, where it's cut down into smaller parts according to specs. The thicknesses range from 6 to 16 millimeters.
This is a scrap material from which the parts are cut. You can see the plate sizes are very optimized from what you were going to cut in them, both in thickness and in width, so you'd have the least amount of scrap. This gets recycled and melted down to make new plates.
Next, the sheets are welded together. This ensures a durable joint between the parts. The welding workshop is the second largest section of the factory, after the assembly line.
It's like a hose, 1.2 millimeters thick, and it's filled with powder. When it comes out of this protective sleeve, where the gas comes from, it melts between 1200 and 1300 degrees Celsius and connects one side with the other by penetrating the material.
Here too, most of the welding work is now done by robots. After the frames and parts have been joined by hand, the welding robots take on the longer welding seams, completing the work of their human colleagues. The A60 is usually used in mines and quarries. A heavier load capability means fewer journeys and higher productivity. Engineers have been developing this system for 50 years. And it all started with a tractor, just like this one.
Anyone who has been operating and reversing in the forest with a tractor and trailer knows how difficult it is. So they started to experiment to improve the off-road performance. Take away the front axle, put in a hydraulic steering, connect with this, and with that, the first articulated hauler was born. Since then, it has developed. The machines have become larger. This is the 860, a 3-axle machine. Now we have the A60. And the A60 is a full articulated hauler. It has an articulated steering. It has an oscillation joint to keep a good ground contact. And we have all-wheel drive.
The A60 is the biggest of its kind. With a length of 12.22 meters and a height of 3.85 meters, it's one of the largest construction vehicles on the planet. Its wheel-to-wheel width is 3.88 meters. Its net weight is 43.75 metric tons. Maximum load, 55 metric tons. That means a total weight of nearly 100 metric tons. Its container can take up to 34 cubic meters of stones, soil, or debris. The A60 is powered by a 6-cylinder inline engine with a displacement of 16 liters and 673 horsepower. The diesel engine supplies up to 3,200 Newton-meters of torque in all-wheel drive. Its top speed is capped at 55 kilometers per hour. No wonder the A60 is affectionately known as the Beast on construction sites around the world. The A60's operational function is the transport of waste material, rocks, and other types of material. A function which is well served by its huge dump body, which can hold up to around 34 tons. Like almost everything on the A60, it's also custom built in-house. The parts which are produced by the laser cutting tools are assembled on a special device. Only when everything fits perfectly can the dump body be fixed on by a process known as spot welding. While in the past welders were almost all men, this part of the plant has also seen an increase in female workers over the years.
This is for eye protection, and when I put this on, this one is become black, that the light don't blend me.
In addition to the headgear, everyone in the welding shop must wear a breathing apparatus to ensure they are supplied with enough fresh air when working. The spot welding of the dump body is complete. This one component already weighs almost 11 tons. But before the dump body can continue to the next stage of the manufacturing process, all of the so-called spots must be connected with one another. This job is handled by a robot, which completes it in an hour. This is also when the exhaust ducts are fitted, since the dump body is heated.
Here you can see how the exhaust ducts are set up, the sheet in front and the sheet behind, so that the exhaust fumes are directed towards the rear, warming up the body.
During operation in cold regions, this dump body heater prevents the contents of the container from freezing. The A60 also comes in a special Arctic version, for use in regions where the temperature can get as low as 40 degrees below zero. But before the body is mounted onto an A60, two more steps are necessary: cleaning and painting. The vehicle is cleaned through a blasting procedure.
We use steel pellets which are launched at the body at great speed, making it nice and clean. And then it's ready to paint.
Before the huge parts are painted, or rather lacquered, random checks are carried out. This 3D laser scanner surveys a large part every day. First, the component is placed inside the machine. Then a contact part fitted with 3 sensors travels around 100 points with millimeter precision.
Here you got the back frame, and we got around 100 point. Red is not good, yellow is.
This dump body has already been checked and blasted clean, ready for a coat of paint. Unlike in the car industry, the choice of color is straightforward.
We have 3 colors to choose between: yellow, yellow, or yellow.
The paint job takes almost 3 hours. After that, the parts can take a little break.
The coat isn't completely dry yet. It needs a little more time to set. That's why we take it to an interim storage site so that it can be processed 24 hours later at the assembly line.
This A60 front frame has dried and is now starting its journey on the assembly line. First, the articulated joint is attached, which will later connect the front of the vehicle with the rear. The holes in the frame are first heated to 150 degrees Celsius using these heating bolts. This makes them a little wider. 15 minutes later, an employee takes the heating bolts back off. Now it's time for the huge articulated joint, whose bore holes have also been heated up.
This is a lot of weight. This is about 600 kilograms. So you have to be very careful when you do this.
The frame and joint are now fused together, held in place by steel bolts that have been stored in a freezer.
This is for the A40 machines, and this is for the A60 machines. And they're a little bit bigger, you know.
The freezing cold bolt is now placed into the preheated boreholes, and it goes in without a hitch.
There you go. That's why we heat them up. They just slide down there.
Now, the front frame is given an identity. Its chassis number is stamped on. It then continues on its journey until it's eventually joined with the rear frame, which is passed through a separate assembly line. First, employees insert the transfer case into the front frame. Then come the two steering cylinders. Unlike a truck, the A60 steers with the entire front part, while the front wheels are fixed and rigid. This allows it to maneuver perfectly on the spot. Two hydraulic pumps are installed for this purpose. Normal steering systems, such as in a truck or a car, would buckle under these heavy loads on rough terrain. The small bolts that are fitted here are also straight out of the deep freeze. The front axle is prepared at a pre-assembly station a few meters away. The next step will be attaching the axle to the front frame. But before that, the huge brackets must be mounted so that the shock absorbers can be fitted. Suspension cylinders like these are almost 1.2 meters long and weigh 105 kilograms. None of these parts can be moved manually anymore, but that's intentional. All workstations in the factory are gradually being set up in such a way that the men and women can access them equally.
That's why we're adapting our workstations so that women and men can work here on an equal footing. Everyone should be able to do the work and go home in the evening without being totally exhausted.
The front frame is now placed onto the axle with a crane. The component now weighs almost 3 tons, and that's before the engine and driver's cab have been attached. The next part to join the front frame is the engine. Known as an inline-6 engine, it has a displacement of 16 liters and around 673 horsepower. The power unit and transmission weigh around 3.2 tons and are placed onto the frame from above using a lifting crane. Change of location. The Skövde engine plant is located around 200 kilometers further north and has been producing engines since 1868. This huge site hosts almost 3,000 employees working across its 265,000 square meters. The center of everything is the foundry. This is where the world-famous Swedish steel is cast.
This is chips from our machining department. We take care of it again. We clean it, and we melt it again. We take care of all our own chips here.
The steel is melted in these crucibles. There are always 2 crucibles heated up. This one is currently holding 20 tons of liquid steel. The slag is removed again and again. That's the dirt that settles on top. The temperature is constantly set just below 1,500 degrees Celsius. Then, a so-called additive, whose exact composition is kept a secret, is poured in to refine the steel. Then the men remove around 1 ton of steel at a time. Small amounts to ensure the crucible always stays at the right temperature. Meanwhile, the molds have been prepared. Known as dies, they're made up of a mixture of very fine quartz sand and glue. The hot steel for the engine's cylinder heads is poured into these molds in just a few minutes. Each die has a left and a right side, which are put together. The steel then flows into the gaps and cools down. Next, the dies are crushed and reused as quartz sand. 40 dies are filled with 1 ton of steel.
It's chilling there inside 90 minutes before we drop it on the carrier who take it down for us. And then you have new products coming in.
The cylinder heads have now cooled down and are lined up ready for the next steps of the production process, most of which will be carried out automatically. To this end, robots bring the cylinder heads from one milling machine to the next. All the surfaces are processed, the ducts drilled, and the corners milled off.
This machine does the drilling from one side to the other to meet up in the middle, and it's the fuel gången.
Each part is sprayed thoroughly with a liquid. This simultaneously cools the tool and the workpiece and rinses off any remaining shavings. The cylinder head seals off the engine's combustion chamber at the top, so there is no room for error here. Each measurement is therefore carefully checked at the test station. To this end, the cylinder head is cleaned first. All measurements are then checked by means of a digital caliper. Then these limit gauges are used once more for additional checks. The blue side fits perfectly, while the red side checks that the hole isn't too big. Simple, but effective.
This one is to check so the hole is not too small, and this one is to check that a hole is not too big. So this one should always fit, and this one should never fit.
After 30 minutes, the test is complete. All measurements are correct. The robot sends the cylinder head to the assembly line. The engine blocks are also on their way. Right now, they're being milled and drilled. More than anything, the bore holes for the pistons must work perfectly. Otherwise, there's a risk of sudden engine damage.
We have many holes. The surfaces are machined. We have done the cylinder holes. And yeah, it's good to go to the next area.
The engine block's journey continues with this yellow robot, known as an AGV, or Automated Guided Vehicle. To do this, the short block engine is bolted to the AGV, which travels through the plant, stopping at each station and only leaving when every component has been fitted. The cordless screwdrivers are connected to a computer which monitors whether all the screws have been fitted. Only when everything is installed can the employee check the engine out of its station and send it to the next one. Then the process is repeated. The AGV moves the engine to its next assembly position.
The AGV knows which position the engine should be in, so it turns the engine automatically for the best position to assemble the parts.
These robot vehicles help produce around 10,000 engines each year, including engines for ships and other truck manufacturers. The A60 engine now receives 3 oil filters, which will later purify a total of 65 liters of engine oil. Then, the flywheel housing is attached. This flywheel is the only used part which is added to the engine. It's only needed for the factory test run.
The used flywheel is only for the hot test in Skövde. After the hot test, we change to another flywheel.
But before the engine can roar for the first time, it has to pass the leak test. First, the unit is filled with air. Of course, all outlets must be closed beforehand. Then air is pumped into the engine. Only when no air escapes can they be sure that the engine is airtight. Then the AGV and the engine separate, marking the end of their journey together. The engine must now pass an initial test run of 120 seconds. If it passes, then it's ready to be painted. All of Volvo's commercial vehicle engines are painted. Before the engine can move into the paint booth, all the sensitive parts must be masked. Then the robots apply the paint in green. There are 2 reasons for this.
paint the engine because we want to anti-corrosion. We paint the engine green because of the tradition and the customer loves the color.
When the paint has dried, the engines are ready to be shipped south to the assembly plant in Braås, 200 kilometers away. This is where the A60 is finally assembled. In addition to the parts that are produced here or in sister plants, up to 50 truckloads of small parts arrive every day. These are then sorted into high bay warehouses like this one and delivered to the assembly line as required. This creates space in the assembly area, but it also requires considerable coordination. It's important that all parts are available at all times.
We have different type of dumpers. So the light one, the heavy one, the one between those two. And when they order from us to deliver, we know exactly which dumper it is they're building at the moment. So then we know which door or which tire they need.
These boxes are filled with all the parts needed for the next workstation, so that the employees on the assembly line have everything at hand. Because any missing parts will cause delays, and the factory runs on a tight schedule. Back to the assembly line. The A60's inline-6 engine has already been installed on the front frame. These special offset screwdrivers tighten the screws from below. Wherever possible, the team tries to avoid overhead work. Once the engine is firmly secured to the front frame, the vehicle is attached to a turning unit called a vandola. It lifts up the 9-ton front frame complete with engine and rotates it 90 degrees. This means that all screws that are otherwise only accessible from below can be easily tightened from the side. For safety reasons, no one is allowed to stand in the danger zone while the vandola rotates the frame.
We used to lie beneath it, but we were working overhead. Lying down for 35 minutes, no one can stand that. So our technicians and engineers came up with the idea of simply rotating the whole frame. And that solved the problem.
Once the vandola is locked in, using ladders and lifts, the employees can easily attach all the screws, which, just a short time ago, were located underneath. After 35 minutes, the process is complete, and the vandola moves the frame back into its original position. At the next workstation, the cooling unit is being fitted. Weighing 150 kilograms, it's the centerpiece of the 90-liter cooling circuit. It seems like a small figure when you learn that the A60's hydraulic system uses almost 210 liters of hydraulic oil. The front frame now has an engine, a cooler, and axles. Now comes the second largest part, the driver's cab. It weighs around 1,200 kilograms and comes fully assembled from the sister plant in Hallsberg. Change of location. Hallsberg, where the cabins and fuel tanks are produced. 10,500 cabins per year for a range of haulers, wheel loaders, and excavators, as well as 15,000 tanks for the Swedish manufacturer's entire commercial vehicle fleet. The plant has just over 400 employees. Female employees currently make up 17% of the workforce, but that figure is rising.
Always when we hire new people, we try to have 50-50% of women and guys to reach the target we have, to increase the number of women in the plant.
Whether it's a tank or a cabin, life begins at the sheet metal bending machine. Ultimately, the cabins and tanks aren't so different. They're both rectangular steel constructions. As with a cube, all side parts are required here. The basic parts for the tank are bent on this 70-ton heavy press. The largest model in the dumper series has 2 tanks each for hydraulic oil and diesel fuel. At the next station, the individual parts are fixed to a template and welded together. The filler neck for later is also attached here. 60 minutes after a tank is stable and its spot welds are finished, it continues to the next station. Now its welding job is being finished in a robot cell. Later, this tank will hold 750 liters of diesel. It's another 45 minutes before all the seams are completely welded. But although the robot can turn the tank in almost every direction, there are still corners that its metal arm can't reach. That's why every tank has to pass a final inspection before being painted. This employee is retightening the seams by hand. Then all the tank's seams are sealed before it's filled with compressed air. A process which for a 750-liter tank takes 10 minutes. The employees check all weld seams for leaks once more using a brush and soapy water. Wherever small bubbles appear, air is escaping from the tank, and the weld seam has to be reworked. Only when the tank is 100% airtight can it continue its journey onto the painting station. These tanks are already painted and waiting for their final assembly, a process which for safety reasons can only take place in a so-called clean room. This clean room is separated from the rest of the factory by an airlock, and normal clothing is not allowed to be worn here. Instead, all workers must wear a synthetic uniform.
We don't want to have contamination in the tanks, because cotton, you can take off particles and have that in the tanks. And in the sensitive hydraulic system, it can stop the complete machine. So therefore, we have this area for we have this overpressure also. So we press out all dust.
The A60H, with a payload of 55 tons, is currently the largest articulated hauler that the Swedish manufacturer has to offer. It was developed for heavy transport operations in rough terrain, such as quarries or surface mines. The dumper is comprised of a sturdy front frame, which supports the engine, and a rear frame connected to the front via an articulated joint. Back to Hallsberg, where the A60's driver's cabs are manufactured. First, all parts are placed in 4 separate boxes, so that the welders have all they need for a complete cab.
These are the parts for the left side, and this is for the right side. And here we have the floor, which we haven't packed yet, and the last one is the roof, where we put them together to have one cab afterwards.
From now on, the 4 boxes will travel through the plant together. This ensures that all the required parts are always in one place. They are then transported by a robot to the welding shop for final assembly, where the metal sheets are clamped onto a frame and then fixed by hand.
This is the left side, which is welding right now, tech welding, to put it into the robot so we can get it to the marriage station to tech weld it to be a complete cab.
In the Gifta, or marriage station, the sides, floor and roof of the cab are assembled. Just like a house of cards, the floor is laid first, followed by the 2 side parts, and finally the roof. Then all 4 components are welded together. Once all the seams are welded, the blue frames can be removed. The cabin is now complete. The driver's cab currently weighs around 600 kilograms. But before it's mounted onto the A60, it gains another 400 kilos of components. Since the A60 is a construction vehicle, it only has one door for the driver, which is now attached to the cabin along with anything else that couldn't be fitted until now. This ensures that all the cab's parts are painted in one go and will stay together. Then the cabin is raised in the air. It's hung on a track system, which carries it through all the painting stations. Before painting, the cab takes a bath for a few hours. This involves feeding every metal part painted in Hallsberg through a total of 18 wash basins. It all starts with a degreasing bath. Several rinses follow before an acid bath, which strips the surfaces and removes all foreign objects. After that, a primer serving as rust protection. Finally, the parts go into the e-coating tank.
A bath with water, with paint inside. There is a lot of water and small amount of paint. And then you put power on, electric, and then you fill the surface. The plate will be coated. And it's very exactly, it's around 20 micro thickness, plus minus 2. So the thickness is very, very stable.
After the primer has dried, the cabin can be painted. In Hallsberg, this is done by 4 robots working in sync. The cab is painted gray. Yellow attachments will come later. Each cab needs 2 kilograms of paint. After 7 minutes, it's fully lacquered. At this speed, the painting station can handle up to 10 cabins per hour. Once the paint is dry, everything is checked again. An employee carries out random measurements of the paint thickness, which should never be less than 80 microns.
It should be around minimum 80 microns up to 200 maximum. But normally around 100 microns for the thickness of the cabin. The less you have, you're saving money also. So the goal is to have 100 around.
Now the driver's cabs are on the home straight, the assembly line. All add-on parts are fitted at the next 26 workstations. Each cycle lasts 7 minutes, which means every station needs to complete their task within 7 minutes. Then all the cabins are pushed one station further. A total of 1,000 parts are attached. Here, the cab receives its steering wheel. And the side windows are also inserted here. The window panes are glued in place. Of the 400 workers in the plant, almost 100 work on the assembly line and in the pre-assembly. It's the largest section of the factory. Around 10,000 cabins for various vehicles are built here every year. At Station 20, the cabin finally gets its yellow roof. The interior is also being completed now. While the other vehicles receive their exterior mirrors here, these are left out on the A60.
Because the A60 is too big, so we had to put the mirrors on the machine for the operator to be able to see behind the vehicles. Otherwise, it would be too narrow if they put on the cab.
Next, the pedal set. Ensuring communication between the driver, engine, and hydraulic system is put in the cab, which is raised so that the assembly is as easy as possible. Now the driver's cab is finished and ready for its last hurdle, the performance test. The test stand, which the cabin is now being attached to, simulates a complete vehicle. This shows whether all cables and lines have been properly connected. If an error were to appear now, the cabin would have to go back to the assembly line for adjustments. It passed the performance test. A forklift picks up the 1,400 kilogram cab plus transport frame and takes it to the dispatch area. A truck then delivers it to the assembly plant in Braås, where the rest of the A60 already awaits its driver's cab. No matter what remote region of the world the hauler finds itself in, digital technology has fundamentally changed the use of construction machinery. Especially in undeveloped areas without real streets or lighting, it's important to know where each vehicle is in a 24-hour operation. Drivers can locate their colleagues and actively avoid collisions in blind spots, even without visual contact. The entire fleet is thus monitored and connected at all times. A real help for drivers in their daily work. Back at the main plant in Braås. Articulated haulers have been built in this plant for 50 years. The A60 is the largest vehicle produced here.
We had problems with the gates between different sections. They were too small, the machine were too big. And then we go to EMC to do that testing. And also at that part, the machine didn't fit into the gates. They also needed to widen their gates in order to get the machine into the correct environment.
On the assembly line in Braås, the cabin from Hallsberg is being attached to the A60, completing the front frame. This is also where the exhaust ducts are attached. Later, they will carry the warm exhaust fumes through the dump body to ensure the load doesn't freeze during transport. Then come the huge fenders, which also hold the side view mirrors. None of these parts can be moved by hand anymore.
The fender can't be lifted, it needs a crane. Most things with the A60 need a crane.
Because each fender weighs almost 470 kilograms with attachments. The driver's access to the cab is also attached here. In parallel with the main assembly line, just a few meters away, the rear frame is being prepared. It has two axles, which are powered together with the front axle. And it houses the hydraulic system, which will later be used to tip the dump body. Just like the front frame, the rear frame also gets its own serial number. Then it's time. The front frame, complete with the driver's cab, engine, and articulated joint, comes together with the rear frame at the next workstation. Both units are connected by the articulated joint, which gives the A60 its name. This joint will later allow the truck to be steered without the front wheels moving, because the entire vehicle will be moving.
This is where the front frame with the driver's cab and the rear frame are joined, bolted together, and finally become a single vehicle.
Now there are almost 100 hydraulic lines which need connecting. Then comes the second fender. The next station is where the A60 gets its fluids. Among other things, 90 liters of cooling water and 210 liters of hydraulic oil. The fuel tank, on the other hand, gets much less. Only 100 liters of diesel for the test drives. Then the vehicle receives its two hydraulic cylinders. Later, these will raise and lower the dump body and will have to support its weight, plus the maximum payload of 55 tons. The hauler is nearly finished, with only 3 workstations remaining. Now, the dump body is attached. This component alone weighs around 11 tons and requires a crane to be attached. Later, it will house up to 34 cubic meters of material. The hinges will be subjected to enormous strain. They are single-part units weighing almost 40 kilograms. The hood and front grille complete the bodywork. Finally, the hauler gets its bulky look. Then the hydraulic cylinders are fitted on the dump body and prepared for the first performance test. Something no hauler leaves the hall without. We have reached the final station of the assembly line, where the engine is started for the first time. By now, everything should be working properly. A total of 50 meters of hydraulic lines and 250 meters of pipes have been laid. These must all be checked again. If the visual inspection is as successful as the test run, the A60 will be approved. But before that, the dump body's hydraulics are tested once more. Now the hauler is pulled to the final assembly station. Due to height and space issues, the A60 only gets its wheels at the very last station. Each wheel weighs 1,300 kilograms and can only be moved with a special forklift. When the A60 was first being developed, there were no existing tires which could support its weight. With the help of a tire manufacturer, appropriate ones were developed. And today, the A60 is adorned with 2-meter-tall, 33.25-inch thick tires. No other Volvo vehicle sports such thick rubber. Each individual wheel is fastened with 24 nuts. A robot takes on this job, tightening each nut with the correct torque. Once the wheels are attached, the team carries out another visual inspection. An employee spotted a scratch on this vehicle's bumper. Although it's hardly the size of a coin, if it's deep enough, then the entire bumper needs repainting.
Luckily, it's just a small scratch, so I can just polish it off here. If it were bigger, I'd have to repaint the bumper, which takes time and delays everything.
Good news, the hauler is now ready. But before it's dispatched to the customer, it needs one last in-house practical test. Just like the smaller Volvo vehicles, the A60 has to pass a stress test on the in-house test track. All the ducts and pipes are checked again. Scratches aren't pretty, but they're unavoidable in vehicles like this, which operate in rough quarries. Hydraulic problems are much more dangerous. And to be able to find them and fix them as quickly as possible, the Swedish engineers have come up with something very special.
This is just a normal lamp, and this is a UV light, which resonates with the oil and shows us if there's a leak somewhere. We put a fluid in the oil that lets us easier find leaks that we can't find with a normal lamp.
The inspection engineer is the last person to inspect the hauler before delivery. Anything he misses could lead to serious, and more importantly, expensive damage during use.
So first I'm going to check with this, and then I'll do the UV.
56 hours of work have now gone into the A60 at the Braås plant. A total of almost 500 employees have worked on it over 7 days. In 2 days, this truck will be shipped to South Africa, where it will be used in a mine.
I'm like the goalkeeper. Before we send it off to its clients, so I have to make sure it's in good condition
Because if it's not, it hurts our name, our brand.
The hauler has passed the visual inspection. Next, the practical test on the in-house test track. Incidentally, any adult with a driver's license can drive the hauler, but only in closed-off areas, as it isn't street legal.
We are checking the system, the hydraulics. So if I try to drive now, it will start a warning. Hydraulic suspension. But then I can just activate it. This is special for the A60.
Should the hydraulics fail during use, the hauler will automatically stall in order to avoid putting the driver in an unnecessarily dangerous situation. Because the vehicle generally transports loads of up to 55 tons uphill and downhill.
We will check it that it comes down within the time range or the time limit.
He also checks the articulated steering, which allows the truck to steer on the spot and maneuver on off-road terrain. The final check is an incline test. The A60 can handle gradients of up to 40%, even when operating with a full payload. That's why the hauler is equipped with 6 forward gears and 2 reverse gears.
We will drive it to the PDI sequence and they will finish it up and put on protective plates, and then if everything is good, we will send it to the shipping area.
An A60 hauler costs well over €500,000 depending on its features. This model is going to South Africa to work in a mine 24 hours a day, 7 days a week. This fully autonomous, battery-powered prototype is the first smart wheel loader, which can make decisions, perform tasks, and interact with humans on its own. It all started with a Lego model, which served as a template. Then it was a case of upscaling. The LX03 is not yet commercially available, but it serves as a basis for the development of a fleet of smart vehicles. The LX03 is a 5-ton heavy wheel loader. It can be programmed to react to different scenarios and will replace humans in overly dangerous situations. Its batteries allow it to function for up to 8 hours, depending on utilization. Another autonomous vehicle, the HX02 unmanned load carrier, was prototyped in 2015. Since 2021, it has been in use at a Swedish steel mill, both in field tests and genuine conditions. Battery-operated, zero carbon, and low noise. It's only a matter of time before these haulers go into production. The A60 is now on its way from Braås to the customer in South Africa. The first stop is the port of Gothenburg. Since the hauler isn't street legal, it's carried there by a truck. Due to its unladen weight of 44 tons, the truck can only transport one A60 at a time. And then there's the matter of size. In order to get to Gothenburg at all, the hauler has to be lifted onto a low-bed truck. Another challenge is the excess width of the A60. In Sweden, any vehicle over 3.11 meters wide must always travel with an escort vehicle. Now the convoy can get going. The Volvo A60 is the largest articulated hauler in the world. It can effortlessly transport up to 55 tons of cargo, bringing its total weight up to nearly 100 tons. The XXL monster truck is built in the main plant in Braås, Sweden. It only takes 7 days from the first panel to the finished A60. Very few parts are assembled by hand. The engines are cast in-house from pure Swedish steel. Every part of the A60 is bigger than the ones for other vehicles in the factory. The dump body alone can hold up to 34 cubic meters of cargo. Even its huge tires were specially designed for the A60. But once the hauler is in use, nothing can really stop it. A tool for the dirty work, virtually indestructible.